Look up. Have you ever wondered what those massive structures are that dominate the skyline near power plants? See those giant towers billowing what looks like smoke? They might seem ominous at first glance, but there's more to them than meets the eye. That's not smoke at all, it's steam. And those towers are cooling towers. The steam you see is simply water vapor, a byproduct of the cooling process. They're not polluting the air, they're helping to create the energy we use every day. These towers play a crucial role in the power generation process, ensuring that the plant operates efficiently. Cooling towers are often mistaken for smokestacks, but they serve a completely different purpose. While smokestacks are designed to release exhaust gases from combustion, cooling towers are all about managing heat. Smokestacks release exhaust gases from combustion. These gases can include pollutants, which is why smokestacks are often associated with environmental concerns. Cooling towers, on the other hand, are an essential part of the power plant's cooling system. They help dissipate the excess heat generated during the production of electricity, ensuring that the plant remains operational and safe. The process involves circulating water through the plant to absorb heat, which is then released into the atmosphere as steam. This steam is harmless and quickly dissipates, unlike the pollutants from smokestacks. Cooling towers come in various shapes and sizes, but their function remains the same. They are a testament to human ingenuity, allowing us to harness energy while minimizing environmental impact. Maintenance of these towers is critical. Engineers and technicians work tirelessly to ensure that the cooling systems are functioning optimally, preventing any potential issues that could disrupt power generation. The design of cooling towers has evolved over the years. Early power plants had rudimentary cooling systems, but advancements in technology have led to more efficient and environmentally friendly designs. Next time you see those towering structures, remember that they are not the villains of the story. They are silent guardians working behind the scenes to keep our lights on and our homes warm. Understanding the difference between smokestacks and cooling towers is crucial. While both are integral to power plants, their roles and impacts on the environment are vastly different. Communities living near power plants can rest assured that the steam rising from cooling towers poses no threat. It's a sign that the plant is functioning as it should, providing energy for our daily lives. So, the next time you look up and see those giant towers, take a moment to appreciate the science and engineering that goes into making our modern lives possible. Not smoke, but steam, a symbol of progress and innovation. Cooling towers are crucial components of power plants, both those fueled by fossil fuels and those powered by nuclear fission. These towering structures, often seen billowing steam into the sky, are essential for the thermal regulation of the plant's operations. They are designed to remove excess heat from the plant, ensuring that the machinery and reactors within can function at optimal levels without the risk of overheating. They play a vital role in ensuring the efficient and continuous operation of these facilities. By dissipating the heat generated during the power production process, cooling towers help maintain a stable temperature, which is critical for the safety and efficiency of the plant. This process involves the transfer of heat from the water used in the plant's cooling system to the atmosphere, a task that is both complex and vital. Without these towers, power plants would overheat and shut down. The consequences of such an event could be catastrophic, leading to power outages and potential damage to the plant's infrastructure. Regular maintenance of cooling towers is therefore essential to prevent such scenarios. Technicians and engineers work tirelessly to ensure that these structures are in top condition, inspecting and repairing any wear and tear that may occur over time. They are the unsung heroes of power generation, quietly working behind the scenes to keep the lights on. Despite their importance, cooling towers often go unnoticed by the general public. Yet their contribution to our daily lives is immense. Every time we flip a switch or charge our devices, we are indirectly relying on these giants of power. Their silent, steadfast operation is a testament to the ingenuity and dedication of those who design, build, and maintain them. So the next time you see a cooling tower on the horizon, take a moment to appreciate the vital role it plays in powering our world. Power plants generate electricity by utilizing the energy stored in fuels like coal, natural gas, or nuclear fuel. This energy is used to heat water, producing high-pressure steam. This steam, possessing immense energy, is then directed towards a turbine. The turbine, connected to a generator, spins rapidly as the steam rushes past its blades. This spinning motion generates electricity. After the steam has spun the turbine, it needs to be cooled and converted back into water. This is where the cooling tower comes in. Condensing the steam is crucial for two reasons. First, it creates a vacuum that helps pull more steam through the turbine, increasing efficiency. Second, it allows the water to be reused, conserving this precious resource. Inside the cooling tower, hot water from the condenser is sprayed through nozzles, creating a fine mist. This mist is essential for the cooling process as it increases the surface area of the water, allowing for more efficient heat transfer. The nozzles are designed to distribute the water evenly, ensuring that every droplet has the maximum opportunity to cool down. The fine mist created by these nozzles is a crucial component in the overall efficiency of the cooling tower. At the same time, large fans draw air in from the bottom of the tower. These fans are powerful and are specifically engineered to move large volumes of air through the tower. The air enters the tower at a lower temperature and is drawn upwards by the fans, creating a continuous flow. This airflow is vital for the cooling process as it helps to carry away the heat from the water. The fans work tirelessly, ensuring that the air keeps moving and the cooling process remains uninterrupted. As the air and water come into contact, heat is transferred from the water to the air. This interaction is a delicate dance where the hot water releases its heat to the cooler air. The process is known as evaporative cooling, where a small portion of the water evaporates, taking the heat with it. This transfer of heat is what cools the remaining water, making it ready to be recirculated back into the system. The efficiency of this heat transfer is crucial for the overall performance of the cooling tower. This process is aided by the large surface area created by the water droplets. The droplets form on the surfaces inside the tower, providing more area for the air to come into contact with the water. This increased surface area enhances the efficiency of the heat transfer process. The design of the cooling tower ensures that the water droplets are evenly distributed, maximizing the cooling effect. The interaction between the air and water droplets is a continuous process, ensuring that the water is cooled effectively before it is recirculated. The entire system works in harmony, creating a seamless dance of air and water that keeps the cooling tower functioning efficiently. Cooling towers employ a clever design called counterflow, which is quite fascinating. This means that the hot water flows downwards while the cool air flows upwards, creating an efficient system. This counterflow arrangement maximizes the temperature difference between the air and water throughout the cooling process, leading to more efficient heat transfer overall. To understand how effectively a cooling tower can cool water, we need to consider two important temperatures, dry bulb and wet bulb. Dry bulb temperature is the air temperature we typically measure in our daily lives. Wet bulb temperature, on the other hand, takes into account the cooling effect of evaporation and is crucial for accurate measurements. Evaporation is the process of liquid water turning into water vapor. This process requires energy which is drawn from the surrounding environment, in this case the hot water from the condenser. As water evaporates inside the cooling tower, it cools the remaining water, much like how sweating cools our bodies. The amount of heat required to evaporate a given amount of water is called latent heat. Latent heat is a significant factor in the cooling process within a cooling tower. The higher the latent heat, the more heat can be removed from the water for a given amount of evaporation, making the cooling process more efficient. The efficiency of a cooling tower depends on several factors, including the design of the tower, the ambient air temperature and humidity, and the temperature difference between the incoming hot water and the outgoing cooled water. Engineers strive to optimize these factors to maximize the cooling tower's efficiency and minimize water consumption. Cooling towers are essential components of power plants, playing a critical role in ensuring their efficient and reliable operation. They are the unsung heroes of power generation, quietly working to keep our lights on and our lives powered. As we continue to demand more energy, the role of cooling towers will only become more crucial in a sustainable energy future.